Talking about LibreCourse I, actually it's one of the projects we started 1 year ago to have opportunity to conduct some kinds of continuous integration of hardware projects and to be able to report metrics on LibreCourse web, including build statuses and of course automatic pull request builds and all other things we may need in open source hardware. So today we are going to provide a short update of what we achieved over last year and maybe to even show some demos. So my name is Eliot Nassif. I am a member of Jenkins project. I am mostly working on Jenkins core improvements and various community and the technical things there. I also contribute to LibreCourse as a part of my spare time activities. And today we are doing a talk together with Stefan. Stefan is one of FOSI directors, and he's working on things like OptimSoc, like he presented yesterday, but he also contributed much to LibreCourse and LibreCourse I, and he's going to talk about some bits of his prototyping work on the instance. Okay, so I'll start from describing what we have now, infrastructure, how would you use LibreCourse. Then Stefan will talk about OptimSoc and things under the hood of LibreCourse I. And then we will talk a bit about future work, and we will appreciate all your feedback regarding your needs, and obviously we can talk after the presentation about the details. So what's LibreCourse I? This is a pretty strange schema, but as I said, it's just an attempt to have a continuous integration as a service for open source hardware projects. So it means that you could run whatever continuous integration flow, including simulation and maybe FPGAs in the cloud. So you get some service, you still need to contribute some infrastructure, but actually you get automated builds, automated testing, and then these results can be reported to LibreCourse web and somehow displayed to users. And of course, if you get external contributors, for example, somebody wants to contribute to your project, he doesn't need to set up his own test environment just to verify his fix. If it's something like one line or documentation patch or whatever, he just creates a pull request on GitHub, on Bitbucket, submits it, then continuous integration runs. He sees the result of testing, you see the result of testing, so it improves both contributor experience and maintainer experience of projects. It's how almost all continuous integration solutions work, and many of you have your own open source projects. You set up continuous integration on Travis CI, on Appear, etc. So this is pretty same thing. The difference is that we want to have some hardware stuff as a part of solution, and that solution is based on specialized framework. So as I said before, we started it in 2016. At the previous ORConf, we were presenting LibreCourse I concept, so just to discuss what we would like to do, and I'm going to talk what we have. So the vision in the previous year was that we have LibreCourse I, which connects to LibreCourse website, which uses GitHub SSO. So it means that this is a service which, for which you could use your own credentials. This service integrates with GitHub, Bitbucket, GitLab. As Philip said, we are not going to have our own hosting of projects on LibreCourse. So we just integrate with existing solutions, which de facto standard for open source projects now. But we offer our own infrastructure. So Jenkins is a main engine we use on the hood of LibreCourse I. Who does use Jenkins in this audience? Okay. Who has no idea what Jenkins is? Okay. So it's just a generic automation server. So think, yeah, you can just consider it as a cron with web interface, for example. It's a bit oversimplification, but yeah, it's a thing which can execute your task and return a result. And we have infrastructure mostly based on Docker. So for example, if you need to run a build which requires a specific IDE tools, for example, Icarus, Yosis, or whatever, You can run it on our infrastructure. We have packages in Docker which provide these tools, and they can be used as a part of the build flow. If you need hardware infrastructure, it's a bit more complicated. So currently, we expect projects to provide their own hardware infrastructure because we still have no opportunity to host much things. It's something we consider for the future, for example, if we get enough sponsorship. But now, if a project wants to deploy hardware continuous integration flow, for example, to run tests on PGEs, the project needs to provide its own peripherals and connects them to LibreCourse CI. And Stefan will talk about how to do it. Okay. So as I said, LibreCourse doesn't provide hardware infrastructure. We also have pretty same problems with licenses. So for example, if you need VCS to run continuous integration for a tool, then we would need to find a VCS license somewhere. It's also a kind of TBD for the future, but now it's a pretty lightweight service. And of course, we would like to focus on open source EDA tools as well, just because it's LibreCourse at the end of the day. But yes, you can bring your own infrastructure. What do we offer now? So LibreCourse now works as a public service. It's available on ci.librecourse.org. But I would like to mention that it's a proof of concept. So effectively, we are working on expanding this service, and the most of the work is not deployed to the public service so far, but it's going to happen in the future. But we offer a reusable Docker image, so you can just download it and, for example, run LibreCourse locally if you want, test your project, and then contribute back to CI LibreCourse core when you have a ready flow. Regarding tools, we offer specific tools, for example, for building LibreCourse CI itself or building EDA tools. So it's a common case when you need to Dockerize particular solutions. And at LibreCourse, we try to generalize these approaches so you could use tools independently of LibreCourse CI ecosystem. And of course, lots of agents. So for example, if you need to run something with few SOC in the Keras, you can just take this image and run it without installing tools locally. And we have several combinations of such images for common cases we support now. Here's an example of what we have on LibreCourse. So as I said, we use Jenkins, and we actively use Jenkins Pipeline. It's a new solution which allows to describe jobs as code. So if you're familiar with Jenkins 1.x, there are big web interfaces with many checkboxes. In LibreCourse CI, you are not going to have it. So everything can be coded. And here's an example of reference built for FuseSock. So effectively, in your repository, you just define a short Jenkins file. You say that you want to run a core build, specify which repo you use, from which organization, then specify node you need to use. So here I use FuseSock and the Keras to run the build, and specify extra arguments. So for example, this is a number of transactions on Wishbone for tests. And everything else just runs and reports results. At the end of the talk, I will show the demo. So how to use LibreCourse CI now? We are going to use it as a service. It's a main use case, but now it's mostly available as tools and as a personal deployment. So I'm going to demo LibreCourse on my laptop, and actually you could do this the same. Regarding tools, I suppose Stefan will talk about available options, and yeah, we can discuss them later. Okay, so that's it from me, and yeah, I'll give you an word to Stefan.
Yeah, thank you. Mm-hmm. So I want to speak a little bit about what we did under the hood to implement the way to access tools, which is like the most critical part, of course, as most of you know. I can click. Oh, you can. So all of you that work maybe in companies or in academia even, like you all face the issue about the tool, like the big forest of different versions of tools and combinations of tool versions that work and don't work and so on. So that's the biggest issue that we face from the beginning, right? So what do you, so like in the beginning we just had one Docker image, which was like few stored very later and everything looked fine, right? But immediately the first project needs a newer version of very later and so on and so on. So that's a kind of common problem that we all face in digital design, right? So you have like multiple tools that you depend on, you have multiple versions of the same tool you depend on, or like in different combinations. And a well-established solution to this is environment modules. So does any one of you know the concept of environment modules? Yeah, it's kind of often found in larger companies, right? So it's a tool you can find in SourcePod, I think, which has the concept of module files. So you have a tree of module files that describe how an environment is set for each tool version, right? So you could do something like module load, very later, and then the version, and it will set the proper version, the environment properly for this one. So it will set the library paths, the normal paths, or like in that case some special variables like the very later root. So you could easily like have several of those calls, and then you have set up your environment, and it's called like environment modules. So they can depend on each other. It could say like, okay, I need some certain version of Python or something like that. So that's what I also used before in other projects, and I found it pretty good fitting for our things. And for what I did then is like a module-based LibreCourse CI declaration in the Jenkins file. So we have our own library which is based on those modules, and so you just import it in the beginning, and after that you can execute shell commands in the environment that you created. So what you do is you say, you do your node definition, and you just say, okay, I need to load this one, and this is just a list of the tools in the version that you need, right? We added just an extra, like you can name them as you want, so we added just an extra layer, which is EDA tools or cross-compilers, for example. Yeah, you can find this library online, and then afterwards, later on, you can just call a CCI shell, and then the shell that is executed loads all the modules that you want, right? Yeah.
Yeah, I should just given it
Yeah,
to you.
that's easier, maybe.
Yeah, sorry.
So what we have now to help people like setting up an environment, for us it's of course for building our own server side, but also if you bring your own agent or you want to run it locally, you usually have to install all the tools, right? And this is where we come into play again, and we provide standard Docker images for all tools that we also have in LibreCourse CI. So it's just always the same. You just do docker run lcci tools / very later / version, and you provide just with the -v parameter, which is like a volume mapping. You just say where in your file system you want to store the tools, and then it will just install like an identical version running for Ubuntu 16.04, which we currently run. It will just do the same installation that we have on the server. So it's like easier to reproduce it. And then in the end, what you do, you just mount it as /tools to the LibreCourse CI Docker containers, like the agents. And then we all have the same tool volume, right? So what it does then, it compiles it usually, or just installs it, or downloads and installs it. We even have some for like Vivado and Quartus. So there you have to bring the installation file, and then it just runs the automated installation inside this volume. And then in the end, you can just like mount this tool's volume read-only to all your instances of LibreCourse CI agents. Or I think in the future we will also like, except for like the proprietary tools, we will like provide pre-built images which you can just like download and just extract locally, right? Yeah, as I said, like it's a good thing to have reproducible builds. The other option, just to tell people, yeah, you have to install this, and then you have to have this module files and so on, turned out like after 3 or 4 tools to be kind of intensive and error prone. So that's the reason we chose this approach. To make all this stuff even more easy, I wrote a simple Python tool which you can install as pip install lcci. With that you can just easily say, okay, I want to install the tool in this version. It has a very simple YML configuration where you just have to provide your GitHub API token, because we don't have any infrastructure beside the GitHub organization that holds all the Docker containers, and it just like the tool just like downloads it from GitHub API. That's why I left this API token. Otherwise, you run into issues if you run it too often, because there's a rate limiting on GitHub. Then you configure the volumes where they are locally on the disk, and that's it. And after that, you could just say, okay, I want to LCCI tool to install this one. And for convenience, we even have like versions, like larger versions of where we make snapshots. Yeah, like LCCI 2017.1 is currently still like a running version update. But this then contains like the current version of very later, current version of Icarus, current version of certain cross compilers that we need. Yeah. It's all just at the beginning. We all know that this can explode easily into very large volumes with a lot of unnecessary tools that you might not need anymore. So what we plan kind of in the background is that you could just say, okay, my project depends on this version, and it will just check that it runs on an agent that has this tool set up, and not rely like on too fine granularity of different tools. We will see how this works. I think this is just something we have to evolve together as a community, which is the best practice here. While I was at it, I also added the possibility to launch agents, even FPGA agents, and this is what we do in OptimSock. So we connect our local Nexus board to a lab PC and just run LCCI there, and then it connects to the infrastructure. It gets an authentication token. So this is what you do when you want to work with us. You ask us, yeah, can I connect my node? And we will just give you the agent ID and the agent secret, yeah, which are both strings. And this is the configuration update. So you add for each agent, you say which kind of agent it is. Currently, we try to get everything to this modules-based tools environment. Then you get your agent ID, agent secret. And what you can also do is you can map devices to the agent. Then, in that case, that's Nexus board. Like it's just the path to the device, and the second one is the path to the FTDI chip, right? Yeah, and then you do LCCI start agent. It launches it, connects to the LCCI infrastructure, and after that, it automatically builds all LCCI builds for OptimSock, for example. Generally, the idea is that you could then, in the web configuration interface, say, okay, I want to provide this agent only to my projects, only to projects from that list, or to any projects matching certain criteria. Yeah, most importantly, the criteria that they use this FPGA for the tester currently. That's kind of how it works then. This is just the example file on 2 slides that we use in OptimSock now, so it's in production. Yeah, what we do, like in the beginning, we just need a few tools like Vivado, FuseSock, Verilator. We need Python 3. We also packaged Python in the tools volume, because every one of you who knows how painful Python 2 and Python 3 stuff can be. That's the way it shows. Then you just have the checkout stage in the beginning, which is identical, and then we have several build stages. One is for the simulation build, then we do some simulation tests. You can see we use PyTest for this, which is like a Python environment for automated testing. So well, as I told yesterday, what it does, it just tests the tutorial steps. So we have a tutorial for OptimSock, and what it does, it just checks like, okay, I want to build a Verilator simulation. Now I want to start it and want to pass the output. Then I want to use we have some TCP or like socket-based connections in there, so you can connect with the OpenSock debug tools to the running simulation, run some tests via this one, like the same steps we explained in the tutorial. Then there's a rather lengthy step of building the FPGA image, so it's the bitstream building in Vivado. And after that, there's a small setup phase where we configure our own Python test environment. And after that, we run automatically tutorial FPGA tests, which is again just written down descriptions as from the tutorial. And it just executes the same steps that we ran on the FPGA. So it downloads the bitstream, and after that, just connects to the FPGA with the OpenSock debug infrastructure and runs some Hello World tests, essentially. Yeah, the same one that we have there. So that's for my part about what we did so far, and this is so like kind of the first steps that we did. I think OptimSock is kind of a proper project for facing some first issues and first troubles, and if you think your project fits into that already, I think it's easily to migrate your project to, just for testing or like bringing the whole LCCI project infrastructure forward. Just get in touch during the next 2 days or next year, how we can go on. Thank you.
Yeah, thank you too. Yeah. So we do not have so much time left. I propose to leave the demo to the lunch break. So I'll be in the lobby and I'll show how it works if you're interested. And we can get into technical details there if you want. Just quickly about the plans. So we have planned pretty many things for this year. Just a status update. So we are definitely doing progress with prototyping. We doing progress with sample projects, but actually we haven't started the beta testing yet, which was our ultimate goal, and we are planning to do it this year. So now we have a good prototype which could be used and which could be reused for different components. If you're interested, you can already start trying it on CI LibreCourse org. In such case, please contact me or Stefan, or you can just deploy it locally and get the pretty same instance. So demo goes to lunch break. Regarding other work we are going to do is to continue working on tooling support. Stefan presented models approach. We also have Docker packaging when you get everything out of the box without models. We want to expand both approaches to support at least all common tools in open source stack we are going to use for demos. We are going to contribute it back. So hopefully with these tools we will set up also CI flows, at least minimal ones, just to verify the status. And of course, you will be able to use these images outside LibreCourse CI as well. If you're interested to contribute in any other way, so here's our root Docker image for the stuff. Here's our repository, GitHub, LibreCourse, LibreCourse CI. And of course, we have our own Gitter channel within LibreCourse organization. So feel free to join this channel and just ask any questions you're interested in. And our common mailing list, which is shared with all LibreCourse developers. Okay, so that's it from us. Do you have any questions? Okay. Yeah, probably not. Okay, if you have any questions, just reach out to us during the lunch break. Okay, thank you.